working with middlewares. Yes, basically this is the main topic which drives your complete request and ends up in preparation of a response. So from the point the request lands on server to the point when the response is rendered to the browser, every middleware is going to add some kind of contribution. So in this particular session, I'm going to cover what exactly is a middleware, how does the run, use and map methods come into the existence for creation of a middleware, how we can set the order of the middleware. Then I'm going to show you how we can write our own custom middleware, and then we will see a lot of built-in middlewares like static file middleware, directory browsing middleware, default document middleware, file server middleware, and there is a very big list of middlewares existing. Now in .NET Core we use middlewares, but in the past we had something called as HTTP modules and HTTP handlers. So today HTTP modules can also be replaced with middlewares and HTTP handlers can also be replaced with middlewares. And it is because of this middlewares only what is needed is loaded. Anything which is not required is not brought into the picture. So basically we can say that ASP.NET Core is lightweight and only the required code is loaded or executed, and that is because of the architecture of middleware. How is it? Yes, we have seen earlier the startup method configure service and configure, two things. So in configure I told you we actually take care of initialization of all the middleware, the complete pipeline where the code has to execute in sequence is constructed in the configure method, and that is all done through a middleware. So middleware is software that assembled into the application pipeline to handle request and response. So when the request comes, it actually comes to the Kestrel server, and Kestrel server will start executing one by one all the middlewares. And what is important is every middleware has some code to execute before the other middleware and after the other middleware. So if I look at this particular middleware, this code is executing before this and this code is executing after this. So before and after the code is executed. That is how you have to understand the middleware cycle. ASP.NET Core request consists of a sequence of request delegates, one called one after the other. So you can see this are all imagined delegates actually. This is a more simple example. You have a request, here some code will execute, and then I'm going to say next. At that point of time it is going to execute the next delegate, next middleware delegate, where extra logic can execute, and this also will execute next, and then it goes here. When there is no next, it will start generating the response now. It start going in the reverse order. So here its own logic will execute, response goes again. What was here before, it becomes after, code executes, after, and the pipeline ends, the response gets rendered to the browser. So each component can perform work before and after the next component in the pipeline. Compulsory, remember, before and after the next component in pipeline some code is executing. Yes, something very beautiful. Every middleware has a choice of short circuiting the request. That means it decides not to call next. Now if it doesn't call next, from here only direct response will go away. These things will not come into the picture at all. So choose whether or not to pass the request to the next component in the pipeline. You can do that. Now why we should do short circuiting? Many times we can get the desirable effect only from the particular middleware and it doesn't have to go to the next one. For example, if I have a static file middleware, the static file middleware is responsible for executing The static pages, maybe the CSS files, the HTML files, or the JS files, these are all going to be executed through the middleware. So if the static file has to execute, does it need to process the complete MVC pipeline, MVC middleware? Not required. So if a static file has been found, it will be processed here. It will do a short circuit and it will not let the request go to the next. From here only it will return back to the browser. So that is, a static file middleware can return request of the static file and shortcut circuit the rest of the pipeline. Likewise, certain middlewares you have to register in advance. For example, a exception handler middleware has to be registered so that subsequently if any of the middleware throws an exception, the exception handler middleware should be able to catch it. It will register its method in such a way that any kind of runtime exception will be caught by that exception handler middleware. So these things you have to keep in mind. But yes, to execute a middleware, we have three main methods which we have to understand: use, run, and map. Now let me create a new project first. I'll create a proper ASP.NET project. We can take anything now, doesn't really matter. We are not concerned with MVC or razor pages. Anything is okay, because we are not going to build pages or request response. Some dynamic output we are not generating. We just want to understand the middleware life cycle. So what I'll do now is, I have all this. Why is it giving error? Let's build it once. A lot of packages are going to be downloaded and those errors will go away. So I will simply comment all this. I'm not using that method, the built-in configure method. I will write my custom configure method now so that I can create my own pipeline. So I do this by using a simple use, app service.use. We have got application builder and application builder.use. You can add a middleware delegate defined inline to the application request pipeline. Something very important. Now here you are supposed to provide as parameter a delegate. Func is a delegate actually. A delegate whose first parameter is supposed to be HTTP context. So here I am using a delegate syntax. This is a reference to a method which is being passed to the use. As you can see here, the first parameter is HTTP context and the next parameter is referring to another delegate. That means next is a function of task. So we get this. These are being given to us when we pass it to use. So what are we going to do here? Here we are saying context.response.write async. Now what this context.response does, remember, for every HTTP request, one HTTP context is created and that lifetime of the request and lifetime of the context is same. So many times when we want to get the request object, the response object, the session object, many other objects, we can get all of them from the context. Now in this particular case, I am getting the parameter as context here, but alternatively many times we can write HTTP context.current kind of thing and get the context. But here we have context. From context, right now we are taking the response, but so many other things are there in this. Request, response, so many. So request context.response.write. We are directly writing to the browser and we are saying before from use 1. Let's say this is use 1. I'm not right now not having use 2. So if I run this in the browser, we are going to get output immaterial of what URL we provide. immaterial of that, we are going to get the output. First, let me do one thing. You see now, before, from, use one. One second. Yes, guys, I'll take your questions before I proceed. Did you understand this? Is it easy? Okay.
Sandeep, this is Jacob. Sorry, I joined late. Can you just brief me? Yes.
We are just learning how the middleware executes.
Okay.
So in the sequential order, I mean, I have commented the original configure method and I'm writing my own custom configure method now. So I'm saying now this order is what it executes and then in reverse order it goes back. So how is the lifetime of a middleware is what we are trying to learn here. This one. Life cycle of a middleware.
Okay. So basically, when we do a request and response, how the middleware comes into the picture is that
Actually, middlewares only do everything.
okay?
The process of creating the controller object, invoking the action method, taking the response from the view, that whole MVC request, MVC which is output generated is also one middleware only. So right now, let me show you this. Pawan, you're asking something? I'm not able to hear you, Pawan.
Yes. Can you hear me? I mean, I was not asking. I was about to ask.
Yeah.
Actually. Okay. So you're saying MVC is also a middleware, right? So is there an option for us to have a middleware after MVC, like before
Yes.
MVC? Okay.
We are controlling the sequence now.
Yeah. I mean, that's what I want to see. Like, can we inject in between it? Okay. Yeah.
We'll see that
I'm
little
sure
later.
you will tell us.
Yeah.
Yeah.
So now, so in addition to the use and run method, we also have the map method. Now, when is map supposed to be used? The advantage of map is it is an extension which are used for branching. All map extensions are used for branching. Now, what do you mean by branching? In the request, we are going to have some path, and based on that path, the appropriate handler will be provided and it will just execute that handler. Say this is the example. I have written a separate method here, just a separate, another alternative way of writing. In case you do not understand the lambda syntax, we just write a separate method. So we have handle map test. As I told you, you are supposed to have as parameter I application builder. Remember, it's I application builder. On that, here we are calling run. Means what? It executes that and finishes, correct? Because we are using run, we are not further letting it go forward. Keep that point in mind. Let me comment this for a while. These three things I'll comment it for a while to make map itself clear. Now, actually speaking, this is traditional syntax where we are giving a delegate instance, and delegate instance is nothing but a method name, and this is the modern syntax. The parameter of this is supposed to be app1. Now what is the app1? I application builder. Do you have to declare? You don't have to. Remember, before implies whatever is there, that is parameter, and after implies whatever is there, that is the return of the function, implementation of the function, you can call it. So implies, and this section is what is here. So this is parameter, this is implementation. So in the implementation, we are simply saying now app1.run, same thing, same, absolutely same. Just that in this case, I have written a separate method. Here I have written inline. Ja, the text is different. So now I'll copy this and I'll paste it here. And let me keep the last one. But what is this map doing? Executing run. Very important. Map is doing execution of run. So here I am saying from non map delegate. Something very important you have to understand. So now if I simply run the project, it's neither slash map1 nor it is slash map2. And if you give anything A, B, C, D, it executes the same run delegate, that is the last one. Same delegate is executing in all circumstances. But now if I give here map1, it says this, and it did not proceed further. Why? Because here I have used run. Instead, if I use, then it would delegate it to the next level. Very important. Provided, of course, we execute next. I would like you to try that. I give here map2 and it executes map test2. So based on this path, if you want to perform an action, and not only that, after map2, if I give A, B, C, D, will I get error? No, it is still going to execute the same map version. The same map delegate is executed. The rest of the path is not picked up by our code, so same output is coming. But yes, if you want, you can pick up that path from our code and execute the functionality. So think of how ASP.NET is now working internally, how the URLs are being picked up by the different middlewares, and each middleware is performing some action based on the path. Think like that and you will understand how deep the concept is. Beautiful concept. And yes, as I told you, if there is no middleware, no code, very lightweight. In the whole request response lifecycle, there will be nothing then. So because of the middleware concept, the beauty here is we are able to induce into the request response lifecycle only that piece of code which is essential to execute, and we are skipping the rest. That's the beauty. What is needed is coming there. What is not needed is getting skipped. Unlike ASP.NET framework, which will load everything into the memory and then only what is needed it will execute. But loading of everything is happening. But here it is not even like that. So request response is very fast here compared to ASP.NET framework, where unnecessary many handlers would execute, unnecessary many filters would also execute. The code will just go through all those required, The whole life cycle is like that. Everything is loaded and everything is executed. Here it is only what is loaded is executed. And short circuiting is a beautiful feature which will let us avoid all unnecessary code when something has been properly taken care of. So this gives you clear picture, clear understanding of three methods which are actually responsible for the request response middlewares. So here you see now, if you do not give any path, it goes to non-map delegate, this one. If you give the path, it executes run of the map 1. This executes the run of map 2. This also executes the run of map 2. Map 3 is not there, so it again goes back to the non-map delegate, this one. Very interesting, very useful code. But actually speaking, we'll never see something like this always in our startup. We have something else. We have got use X, use MVC, something like that we see. So how is that architecture of use actually implemented? How is this use exception, use HTTPS redirection, use static? What is this use? These are all extension methods which are extending I application builder. So how exactly we write an extension method so that we can put our own custom middleware within the configure method without explicitly showing to the user the run syntax or the use syntax or whatever. How can we make it simple? That's what we will see in the next session. That's all in this. Thank you.